we're going to start a unit over systems of equations. Okay, well, you guys have already done systems. Last week, when we were working with systems of equations, if I asked you guys to solve a system, the method that you guys used last week was graphing them. So what you were just quizzed over, I would have you guys graph two lines. You were looking for their point of intersection. So majority of the time, you guys would do this. You would graph your two lines, and then you would write your answer as an ordered pair, right? Wherever they crossed, that's what you guys would say was the solution to the system. Well, now, instead of doing graphing, I'm going to teach you guys a method called substitution, which the concept of substitution is not a new concept for you guys. We have taken numbers and done plug and chug with them before. Anytime I've told you guys to plug in a number, that is substitution. You take the letter out and you put the number in its place that it's equal to. Okay, so we're still going to be doing substitution today. But sometimes you might be just plugging in a number. Sometimes you'll have to plug in an expression. So you might, instead of plugging in the number 4, you might have to plug in x minus 4. Okay, so we're going to learn how to solve a system of equations using substitution. Okay, that way you have another method to solve systems without using a graph. Because if I don't give you the graph, you guys can't graph the two lines to see where they cross. So you have to find some other way to identify where the two lines would cross each other. Okay? Turn the page. Turn the page. We don't need that page. Turn the page again.
Turn 2 pages.
Yep. All right, so this is just kind of what we were doing last week, right? This is, they've graphed two lines, and it says estimate the solution. So, you know, I don't really like to do these when they're not whole numbers. There was one on your quiz yesterday that when you graphed them, the two lines did not cross at whole numbers. And so I told you just don't even worry about putting the ordered pair down. I said just show me the graph. If you look here, it's definitely at the 5, and then it's not quite down to -1. We'll put like -3/4, -0.75. That would be just like an estimate. Now, I'm not going to give you guys ones where it's fractions. They're all going to be whole numbers, but they're just saying give an estimate. Even with this one here, they want you to choose which one you think would be the best estimate for this. So what do you guys think about this ordered pair? Like the x falls between 1 and 2. Which of these falls between 1 and 2? 1/2, -1/2, 1/4, or 3/2? Huh? Wouldn't 1/2 be right here, halfway between 0 and 1? And 1/4 would be 1/4 of the way between 0 and 1? How do I know that this one is between 1 and 2? You guys, how many times does 2 go into 3? Once, right? So it's 1 point something. 4 does not go into 1. 1/4, 1/2, and -1/2, those are all less than 1. If your top number is smaller than the bottom, it's less than 1. But if your top number is bigger than the bottom, it's bigger than 1. So if we're looking for the one that's between 1 and 2, it has to be this one. It wouldn't be negative, because negatives would be over here. All right, turn the page. Okay, so this is just a definition of what substitution really is. It says a method of solving a system of equations in which one variable is isolated and we can plug in its value to solve for the opposite variable. Okay, Okay, so we're going to take one letter out, we're going to put something in its place, and then we'll be able to solve for the other letter. Why do we need substitution? Well, as you guys could see back on that graph, estimating where they crossed was not really very accurate because we had to estimate. We do not always have a graph to use to solve a system, so substitution is just one other method to use when we don't have a graph. All right. Now this is the important part. When will we be using substitution to solve a system of equations? It says if at least one of the equations in the system has a variable by itself. So look at this system right here. The top equation, the x and the y are on the same side, so neither one of those are by themselves, right? But look at the bottom one. Isn't y isolated? Since there is an equation where one of the letters is by itself, this would be a really good problem to use substitution on, because I could take this, so look up at the board, I could take this expression here, plug it in up here where the y is, because doesn't it say this equals y? Even though they look different, if it tells you that this expression has the same value as y, I can take y out and put this in its place. The benefit of doing that is if I put this here, won't I just have x's in my equation? If I take the y out and put this in, the y's are gone and all we have are x's, so we'd be able to solve that for x. You can't solve an equation that has an x and a y. Okay, this one over here. Do I have either letter by itself? No, but could I, like on this one, could I get that y by itself? How could I do that? What term would I have to move? I would just have to move the negative 3x, and how would we move a negative to the other side? We'd add it, so it would become a positive 3x on the other side, and then we'd still have the minus 4. So now, isn't this isolated? Yeah, we could take this, and we could plug it in to the bottom equation right where that letter y is, since it says this is equal to y. Again, you know, in math, things don't have to look the same for them to be equal in value. You guys should all know those two fractions are equal, aren't they? Because 4 is half of 8 and 1 is half of 2, so they represent the same amount, like the same value, but do they look the same? No. So in math, things don't have to look the same, but they can still be equal. So if this is equal to y, I'm just going to take that y out, put this in its place, and then finally we just have x's involved and we don't have two variables, we just have one. Okay? Go ahead and turn the page. Turn the page, please. Okay, so we have already learned, you can tell I didn't type this. We have already learned substitution when we evaluate expressions for a given value. So like here's our expression, and they tell you x is equal to 4. Well, what am I going to do with that 4? Put it in place of x, wherever we see an x, right? We see an x here and we see an x here. So what we would do is we take x out, put a 4 in its place. You guys need to be watching the board. Put the 4 in. Now everything else is going to stay exactly the same until we get down here where there's another x, and then we'll plug in another 4. Order of operations. What do I have to do first? Order of operations. Starts with a P. Yep, we're going to start with our parentheses. So we need to do this first. What's 12 divided by 4? 3. Everything else you guys would want to bring straight down. Okay, now after parentheses, what's the E stand for? Exponent, so isn't that this? What's 4 squared? 16. It means 4 times 4, 4 times itself. Okay, so now we've done exponents. After the P and the E, there's an M and a D. Multiplication and division, you do whichever one comes first. Well, is there even multiplication or division in there? No, so then we go to addition and subtraction. How do we do addition and subtraction? Left to right. If you have both addition and subtraction, just because the A is listed before the S in PEMDAS, you just do whichever one comes first, left to right. Now in this example, the addition did come first, right? So we would start here with 16 plus 5. 21 minus 3. 18. Okay, down here at the bottom, here's the expression. They have told us a value for C. So wherever I see the letter C, what number are we plugging in? A 6. And wherever I see the letter A, what number are we plugging in there? 5. And what does it mean if two letters are side by side or two numbers? We multiply them together, right? Okay, so if we rewrite this, 4 is first. What number goes there? The 6. Plus, and then A and C are going to be side by side, multiplied together. So I usually just show them in parentheses. So A was 5, C was 6. The minus 2 is there, and then what number goes next to the 2? 6. All right. Obviously, there are lots of parentheses in there, but in order of operations, when they say parentheses, they're talking about a set of parentheses that actually has like an operation in there. These don't have operations in them, so there really are no parentheses that we have to start with. We do, however, have an exponent. Right? This part, 6 squared. Anybody know what 6 squared is? 6 times 6 is 36. Okay, so all I've done right now is exponents. Now look up. Multiplication, multiplication, multiplication. We have 3 multiplication problems here. We can do them all at the same time. We just need to make sure we bring down these symbols. Well, let's start with the easy ones. 5 times 6, 30. 2 times 6, 12. So now 4 times 36. Get to typing. 144? 144? Okay. So now we have addition and subtraction. So now we're just going to go left to right. 144 plus 30. 174 minus 12. 162. 162. So when I said before that the concept of substitution is not new to you, it's not. You guys, what we just did there is substitution. We took letters out and put values that were equal to those letters in its place. Just like in sports, when you substitute a player, the idea is to take someone out and put someone in its place or in their place that's at least as good, right? That's the goal. That's what we would want to do. That doesn't always happen, but all right, turn the page. So now we're going to do substitution with, sometimes it might just be a number, but then like I told you guys before, sometimes it might be an expression. So step 1, make sure that we have a variable by itself. If we don't, we're going to have to make sure we move stuff around to get that. Step 2, substitute everything that the isolated variable equals into the other equation. So you're going to take an expression and you're going to plug it into the other equation. Okay? Step 3, solve for the variable using, so if there's only x's in the equation, we're going to solve for x. If there's only y's in the equation, we're going to solve for y. Step 4, once we have one answer, so like if we solve for x first and it says x is equal to 5, we're going to then plug that value into either equation to solve for the other letter. Because our goal, our end goal is to end up with the ordered pair of where the two equations would cross each other. Yes? Well, we're not ready yet.
Well, I was.
Well, I'm not. Okay, so everybody take a look down here at focus question number 1. Which equation has a letter by itself? The top one. So this is what I want you guys to do. Whichever equation has the letter by itself, I want you to put a box around what that letter equals. Now here's the good news. Didn't they just give us the value of x? And at the end, aren't we looking for an ordered pair that starts with x? Good news is we already have half of our answer. We just need to find y. Okay? So this is what we do. Are you watching? You take this number, which is equal to x, and we're going to plug it into the other equation where that letter was. So here's x. We're going to physically take that x out, and we're going to replace it with a -2. So we're going to write negative y plus 7, and now instead of putting x, what goes in its place? -2 equals -10. See now, don't you only see one letter? That's good. We only want there to be one letter, okay? So now we do have to do this multiplication here with 7 times -2. -14. And then what would I do to solve this equation? Add 14 first. So then we have negative y equals what? What's -10 plus 14? 4. Now, if there's a negative sign here, what does that mean? Negative what? 1. So don't we have to divide by -1 to finish this? Yes.
I did it different, but I got the same.
I don't know how you would have done it any differently. -4? No such thing.
Oh, I believe that there is. Especially with
Okay. What do you guys think? Was that okay? Well, I will tell you, this is as easy as they get because we already knew one of our values. So if we already know x or we already know y, we already have half of our answer. So we're really just finding the other half. Okay, once we do some of these others, you're going to see they're not all going to be that simple. Like, take a look at this next one. Okay, which equation has a letter by itself? The top one. Okay, the y is by itself, so whatever y is equal to, put a box around it like I've told you before. No, whatever letter is by itself, put a box around what it equals. Because this, if you guys could actually picture this, okay, we're literally picking up that box, and we're going to put it in this equation wherever the letter y is. Okay, so like, isn't the letter y right here? So we're going to write this bottom equation as is, so like negative 2x minus 4. But then instead of putting y, what are we putting in its place? Whatever's in the box, right? Negative 8x minus 23, and then equals 2. So I'm trying to show this to you as organized as I can. Look up here. This is equal to y, so I put it where the y was. But everything else that's in blue, this is the original equation. I just took the y out and put something in its place. Okay? Now, when you're looking at this equation, we only see x's. That's great. We need the equation to only have one letter in order to solve it. So now, how am I going to go about solving this? Like, what do I have to do right here? The distributive property, where you're going to take this times this and this times this. You guys have all done plenty of those before. Negative 4 times negative 8x. 32 what? X. Negative 4 times negative 23. And it was positive, right? So since it was positive, put a plus. All right, so once we distribute, is there anything that we can combine? What? The x's right here. So you guys need to add together the negative 2 plus 32. Should be a 30x plus 92 equals 2. Okay? Then what would we do to solve this? This is a two-step equation. Subtract 92. You got to do the addition subtraction first. So we have 30x equals, what's 2 minus 92? Negative 90. Now we can finish with division. Divide by. So x equals what? Negative 3? Yeah? Okay. Now, we just found x, which is great, but don't we still need y? Okay. Remember that box I had you guys draw up at the top? That serves two purposes. First purpose is that shows you what to plug into the other equation. But now, knowing that we have x, like I know that x is negative 3, and this is how I find y, wouldn't it just be easiest to plug this negative 3 in right there, figure out what's in the box, and then that equals y? That's why I always have you guys do those boxes, because it should remind you, hey, once I find my first answer, plug your first answer into that box, and then you'll have the second answer. So we would do y equals negative 8 times a negative 3 minus 23. So I'm plugging that first answer in right there. Now, all you guys have to do is type this side into the calculator and it'll do all the work for you. As long as you type it in right. You should get 1. Type it in, see if you guys get a positive 1. Huh? No, I mean, this is a little bit harder, for sure. But it's taking all the skills that you've learned, like we've learned substitution other ways. We've learned how to distribute, we've learned how to solve multi-step equations. So it's taking like lots of individual skills that you've learned from pre-algebra and algebra 1, and it's putting it all into one problem. All right, let's go to the bottom. What do you guys think? Which equation has a letter by itself? The bottom one? Put your box right there. Where am I going to plug negative 8x plus 20 into?
11.
Yeah, next to which number?
Negative 30.
Okay, does this say that it equals x? So you wouldn't put it, you're going to put it next to the negative 5. So we're going to take this and we're going to put it right there because it's equal to y. So we would rewrite this top equation, negative 3x minus 5, and then instead of putting y, we're going to put that box in its place. Of course, I'm going to put it in parentheses, but you see what I'm saying. Distribute? Yeah? Is that what you were saying, Trinity?
Yeah.
So we're going to do negative 5 times both of those? Yeah, that negative 3x just comes down, so then you guys need to distribute. Huh? Positive 40x? Uh-huh.
Yeah.
Yep. Keep going. Negative 5 times 20. Negative 100. Okay. Then what? Combine these. Negative 3 plus 40.
$37.
37x, and then just copy the rest of the problem down.
Don't show it.
Then you do what? Add 100? Yes. So 37x equals 111? Ew. This is going to be a decimal, isn't it?
Yeah.
Oh, no, it's just 3, isn't it? If you divide 111 by 37, yeah, I wasn't thinking. X equals 3. We shouldn't get decimals. That would just be a pain if we did, because then you'd have to plug a decimal into the other equation, and that would not be fun. So I always try to give you guys problems where there'll be whole numbers. Okay, so we have our first answer of 3, and it is x. So now, how am I going to find y? Plug in the x to the box, right?
Yeah.
That's going to be the easiest place. Now listen to me. I need you to look up here and focus. This x, I could plug it into this top equation where the x is, but then I'd have to solve like another 2-3 step equation. If I just plug it into the box, you just have to use order of operations on that side. Okay, so let's do that. Let's go up here and put y equals -8, and then I'm going to put a 3 next to it, plus 20. What is it?
44.
No, it's not.
Huh?
-8 times 3 plus 20. -4 is what you guys should be getting. -4. And I am always going to be looking for the ordered pair at the end. Like that is the answer to the problem. Questions on either of those? All right, turn the page. This one's my favorite kind. Okay, just listen. If I tell you that A is equal to 5, and then I turn around and say B is equal to 5, if these two have the same value, what's true about A and B? They're equal, right? Okay? So using that concept, look here. If y equals this, but then they turn around and say, wait, y also equals this, what has to be true about these two? If they're both equal to y, don't they have to be equal to each other? So we're just going to set the two boxes equal to each other. We don't even need the y's anymore because I can put this one right here and set the two expressions equal. So I'd have 3x plus 11 equals -3x minus 7. Yes, Kylie? So now this is just a multi-step equation that has variables on both sides. So what would you guys do to start solving this? I probably want to move this one this way. That's just my personal preference, yeah. So I would add 3x to both sides, get all your x's to one side. So 3x plus 3x is 6x. I'm just going to bring this other stuff down. So plus 11 equals -7. Then how do I move the plus 11? Subtract 11. -18. And then divide by 6. What kind of 3? -3. We had a lot of 3's, didn't we? Okay, so our first answer is -3. Now here's the good news. Usually, once you get your first answer, there's only like one box to plug it into. Well, here, couldn't we plug it into either box? I mean, either one is going to give us y, so you just pick one. It doesn't matter. I think the top one looks easier because everything's positive, isn't it? So I would probably do the top one, but if one of you guys wants to do the bottom one, you can. So I would do y equals 3 times -3 plus 11. And whatever you guys get, that's our y value. Two? Is that what you said? 2. That would be correct. How do you guys feel about that? Is that okay? Those are the three different types of substitution. This kind I would consider to be, well, actually, let me go back to this one. The very first one I did, if I were to rate these, like this one here was the easiest one because they already gave us one of our answers. So I would consider that focus question number 1 the easiest. The fourth one that we just did, if I had to rate this, I'd say this is like medium as far as like difficulty. These two here, questions 2 and 3, these, in my opinion, are going to be the hardest ones because you're plugging in an expression to another equation. And most of the time when you do that, you're going to have to distribute and combine like terms. So there's a lot more work involved on these two than the other two. Okay, so down here at the bottom, these are going to be, well, they put freak occurrences, but it's more just like, these don't happen as often. Normally when you guys are solving systems, you are going to get an X and a Y. But I want you guys to see what happens down here. Okay, which letter or which equation has a letter by itself? This one, right? Okay, so we're going to take that 4x minus 2 and we're going to plug it into the bottom equation where the y is. So I'd start off by writing negative 8x plus 2 and then in parentheses put that 4x minus 2 and then just finish the equation. So now, what are we supposed to do since we've plugged in that expression? Distribute. So negative 8x plus, yeah, I brought down the negative 8x out front. So you were a step ahead. 2 times 4x is 8x, and 2 times negative 2? 2 times negative 2, negative 4. Now look what happens. If I pair these two up, what happens? Don't they cancel each other out? Okay, so look, you get a statement that says negative 4 equals negative 4. Is that true? Does negative 4 equal negative 4? Okay, if that is a true statement and all of your x's have disappeared, what that means is it would be one of those problems where there are infinitely many solutions. Now, like I said before, this is not going to happen very often. But if you ever are doing substitution and your x's cancel, you're either going to be left with a true statement or a false statement. If it is true, that means no matter what number we plug in for x, and what number, so if we plug, let's say we plug in a 3 for x here. 4 times 3 is 12 minus 2 would be 10. 3 and 10 would also work here. If I plugged in a 4 here, which would make 4 times 4 is 16 minus 2, which is 14. If I plugged in a 4 comma 14 here, 4, 14 would work there too. Any two numbers we plug in will be true in both equations, okay? All right, turn the page. Probably going to do one that ends up being false. Yeah. Okay, this one. Top equation has y by itself. Has y by itself. So we're going to plug that in where the y is. So this bottom equation I'm going to rewrite, but instead of putting the y next to the 4, we're going to put 5/4 x minus 1. So we're going to distribute. Now you guys can type in 4 times 5ABC4. And you get a positive 5, so that'd be positive 5x. And then what's a 4 times a negative 1? Negative 4. Now see, look what happens here. These two cancel each other out again, don't they? But look at what's left. Negative 4 equals negative 8. Is that true? That is a big false statement. They are not true. And so when it's false, this is the type of system it is. When it's false, that means that there are no solutions. And if there are no solutions, doesn't that mean they were parallel to each other? Because they would never cross. Okay? What do you guys think? Can you do some of these, you think, on your own? Well, let's see. I would like you guys to try this one without me. There is a multiple choice, but I want you guys just to try this one because this is the hardest type. See what you can come up with. Take what's in the box, plug it into the bottom equation where the y is, and see what you guys get. Work it out on your own. I'm going to freeze the screen so you guys can't see what I'm doing. But I want you to try it on your own, see what you come up with, and then we'll compare. Okay, so what did you guys come up with for your x value? I got a negative 3 also. So now, the good thing about having multiple choice is we know it's one of these two, right? We know those are out. But we still need to take that negative 3 and plug it in up here. We would do 7 times negative 3 plus 16. What'd you guys get? This would be negative 21 plus 16. So there would be 5 extra negatives, not 5 extra positives. So it's letter C, negative 3 comma negative 5. Nice job, guys. I'm going to say this. If you were able to get negative 3, that's great. Because you guys have only seen a couple of examples, and if you were able to do this kind, this is the hardest kind. So if you were able to do this and get that answer, you just did 80% of it completely on your own. Good job. I'm proud.